是说那个关于就是为啥呢？问意思。Purpose. What do you want to do? Yeah. And that's what makes it very loud. Yeah. Yeah. Well, how you got back into it? We're gonna figure out whether for dinner, we're gonna go on dinner. Sorry, we must be back to the things. Exactly. So what I'm looking at. You think that was from fundraising? No, I'm using chicken. Yeah, maybe you said. There's other 40 questions or 40 questions. Not 50, but you see, probably this like reach. I got these. Because I'm trying to pick up what I guess I'm using something very yeah, I need to try. Because once I get my things out, I'm just trying to go and for 80, I can take it. I'll do the rest.
Okay, this is the last lesson of my lecture. I remember we have a guest speaker on November 28th and logging anywhere. You get extra credit, 2 points extra credit if you attend. Make sure you get a screenshot in case I didn't have time to count the number of attendees. Okay.
What time is it on the 28th? What time is that?
Same time, 11 o'clock.
Okay.
Yes. Because I think it will really benefit you to learn the trends and interesting projects that they are doing, and also learn some career opportunities there. So I'm very excited about that. Today we'll talk about deploying the model, prediction model, as a REST API with the web framework Flask. So the beginning, we'll review some basic concepts. What is an API? So like in Python, we are developing prediction models. It's written with Python, right? And when you need to develop a client portal, then usually it's a website. It's written in JavaScript. Right, usually the data is in JavaScript or C#, and these are 2 different languages. So the API is basically you define how these two applications, two interfaces communicate with each other. And now it's usually is the JSON. In the past, they use XML, JSON is kind of the standard. So API basically is you define the way 2 applications find a way 2 applications communicate with each other. And the REST API, REST stands for representational state transfer. It's an architecture to support the communication. So this API could be scalable and some other scalable and other benefits. High performing and those other kind of benefits. Okay. And if you are interested in learning what are these constraints that they defined for this architecture, you can learn at this link. Okay. So now, for example, so now I have a prediction model with Python. Or maybe it's not a prediction model, but I have a database with a database, and I use the Python as a backend, software to build the backend software to communicate with the Python. Okay, to communicate with the database. What we need to do, for example, now I have a task. I want to get the user's information from the database. What I needed to do is to just build an API. For example, this one, I get drinks or get users information from the backend. Get users. And if I need to get a specific user, I can give it a key, like a ID is 5 or ID equals meaning, then it will get the information about me, right? So usually if you need to get a specific element, okay, you define it here. Okay, so next, so here we have an API to get the information from the database. And now I need to present it to the user and receive request and get the data. And I need to present it to the user. So here it will be a front end portal. Maybe it's in JavaScript or other language. Here, this gives it the request, and then it gives the response back to the front end. So one question is why we couldn't just use this front portal to get data from the database? It will be much simpler. In the old time, like when I first learned the building website, we did it in this way. I use ASP. The older session .asp, use ASP, and we do this. We do this just a connect to the database and then fetch the data, give it, return it to the user. So, but it's kind of an old-fashioned, outdated now. But this is a more current standard way to build a website, right? Like if you see a web developer application, Angular or React, those are the requirements for a web developer position. So why don't we use this way anymore? Yes, security. Oh, we did the web scraping for one of our lessons. If you here, if the user developer inspector inspection, and then you can see how he gets this web page gets the data from the database. So that exposes the database. Security, that's one of the reasons. And the second reason is adaptability. For example, here I have other information here stored here in this API. If I need to not just present it at a website, but I need also to access it from a mobile device. Or this mobile device maybe use may use a Swift or other language. Okay, I can just insert here, add another application, another front-end portal. And these two portal access the same API, get the exact the same data. So, and that's the second reason, adaptability. And the third one is the third reason is what we call modularity. I believe I spelled the word correct. Or not. Modularity, which means maybe at some point I want to use the Python to read the database anymore. So I can swap it out. But this part, maybe the connection of this API and this backend need to be changed. But all these here still can be used because they connect to this API. Right? They don't connect to here. So this modularity really saves time if you if you later change the backend or update something. And the last one is we call interoperability. Actually, it's kind of like a capability to collaborate. So here, so we don't want to open database or open this part, right? Open the database. Or we could open this part, the API part, like Twitter. They all have API, the developer platform, and they open some of the API, some of the get the data from the database and open here the API. So a lot of the developers they build interfaces and they build applications upon this one, but it doesn't affect the database. So that increase the capability to collaborate, and a lot of people can work on that. Now you can open it to the public. Okay. So there's some basic concept about REST API. Next, so when we say these methods, the front end request data to the backend. There are several basic requesting methods. One is the GET. It is retrieve data, and POST is write data. Okay, insert data, SQL, insert data and delete, and put is update the old data. So these are 4 requests you can write. And Flask is just a web framework, like Angular, like React. So with the web framework, they define the templates. They give you the templates. Hey, where do I store the HTML? So where do I how should I name the Python files? So if another developer take over your project, he can easily find everything, right? Also, the web framework, they give you the templates for the basic elements. So this is the web framework. What is the web framework for? And the Flask is written in Python, so that's why we use it for deploying the Python prediction models. Okay, and let's start our project. So the first step is still we have to go back to the prediction model. So we have we built a lot of the prediction model in the previous lessons. In the previous lessons, we developed a lot of prediction models. So what we have to do if we have to deploy to this, deploy to as an API to, and then to return it to the front photo. If we look at the picture, okay, here, for example, this is the front photo view, a website, and read the data. You can input a height, weight, and then here it should save the it shows the linear regression model, and then it uses here it transfers the data to the Python, right? The Python, the API transfer the data, and then here the Python should save the regression model and give the data to predict, and then return it to the API. That's all we have to do. Okay. So the first thing we have to do is to save this prediction model to Python. Save this model to Python. We have built the prediction model. For example, here I built a decision tree model. Decision tree model. So this decision tree model, the final tree, I only used one depth. I mean that just one criteria. However, when I built the model, I used several features. Used almost all the features. Because I just used the project to demonstrate the algorithm. So I didn't do good at processing the data, cleaning the data. Okay, so I used all these features. So and now we want to save this model. To save this model, okay, save this model prediction model. What we use it to use the Pickle library. It can save the model to a separate file, Pickle file. And what it saves is the model, the model calculates the features and also how many, what are the features it taken. So here I just dump this model into a Pickle file. Okay, now this model, this is the name of the model I defined earlier. And this means that write to the Pickle file. Write to the Pickle file here. Okay. Yeah, I guess that's it. I'll name it as a model 3 Pickle. Okay. Now with a new just open a new file. Okay. And now with I saved it. Now I can load this model and then use this model to predict a new data for right. So here this is the file name. I believe I is the model 3. And here read only. And name this new model or decision tree model. Now I loaded this model and use a new variable to save this model, and I can just use this model to predict the data. And give it the exact variable as we used it when building the model. They will return the result. Okay. So here, for example, I had all these features. So you see, it's a quite complicated model. Predict. Okay. Okay, give it a gender 1, married, just 1. So that's another reason why we like a smaller and simpler prediction models. So you can have fewer inputs, credit history. It's actually the most important feature. Yeah, I think that's it. Okay. Model suite. Okay, still returns an error. So let's look into it. Okay, again, our prediction model, they all take us to the array. So you have to do it to the array. Okay, it gives us a result. 0. Let's go back to see. My credit history is 0. If credit history is 0, true, then returns 0, and false. If credit history is false, it should return class is 1. So let's see. I'll give it 0. Credit history is 0. Yes. Oh, let's see the probability of this model. So probability should be 0. Yes. Okay. Yeah, often confused with this decision tree. So if it's 0, credit history is true. Oh, so if credit history is 0, is smaller than this one, then the class returned should be 0. So we use the 0, so this should be 0, and the probability is 96%. 96%. 96% is 0, and 3% is 1. So this is correct. How do we get this 96% here? If we go back to this decision tree, so in this case, 128 cases are 0, and the 5 cases are long. It's predicted as 1. So add together is 126 divided by 131. That's the probability of getting 0. Oh, that's correct. Okay. Okay. So we tested this prediction model. Looks correct. Looks correct. Next, we need to do, instead of loading it in a Jupyter file, we can load it in a API, in our API, and then use it to predict the data. Okay. What we need to do is to use here Visual Studio Code. Here I'll build this project, and we mentioned the 3 files. One is the Python file, the pickle file that saves the prediction model, and the other one is the index file, the client portal, and then the middle one is the API. So I just go over that. Okay. First, you need to do is to here just create a file for your project. Example, decision tree model. And in this, yeah, so I'll just load this to my workspace. I'll add this folder to my workspace, this project to my workspace. This is a new project I'm going to work on. And I save what we need to move the pickle file into here, right? Here. Pickle file. Pickle file. And the next, we create this is this API. Let's do this API. Did I go in the wrong? So I created an API file, and the first thing is to import some of the libraries, and then the first thing we do is to create a first instance for this API. So usually it's named Flask. So this is just a convention is we usually follow. That's the first instance for this API. And the next thing you do to is we can just create a very simple. Oh, it's not moving. The next thing we do is that we can first create this a simplest website, hello world. Okay. That's the app. And this is just the route, like when you first enter the website where it goes. So the first route is the root of the website. This means that goes to the root of the website. And when we go to the root of the website, what should we do? We can return this is to, what do we return? This is to read the index, read the HTML files. So this yeah, this one is to read the HTML files. And so, for example, here I can just if it comes to the website, the root of the website, we will read the index file. Okay. Okay. So yeah, that's how we need to create the simplest website. But by now we haven't created this index HTML file. What we had to do, so for the Flask framework, all the HTML files, they are saved in a folder called templates. So we need to create a template under this project. A folder template. Okay. And under this folder, I can create an HTML file. Okay. And with this HTML file, okay, I just use this one. Okay. Basic body template, and here this is a simplest website. So it's just what it has is hello world. Okay. Okay, here we have this HTML file ready, and we have this API ready. And the last thing we have to do is to tell the app to run. So this one at the bottom means if this instance is the main instance, then run this app. Run this app. Okay. This debug true, you can skip it and you can add it. Oh. And now we can just run it. I think we have everything here. Okay, looks it didn't return any error. So let's see this portal. We should have our hello world. Okay. Object. So this it tells us this function object has no HTML. Let's come back to check it. All right, here. Okay. Try again. Just already in use. Oh, you see. I believe that's because I run the old one. So now when I run again, I try to run it again, it tells me it was already in use. it still tells us that it's already in use. Um, let's see what we can do with this. Error 48 address already used. So okay, refresh it. It was already running, so I refreshed it. Okay, it works fine now. So we finished the first step just to build a simple Hello World website. So next thing we have to do is to get the input from the index, right? Instead of using this index, using this index, we have to define a more complicated index like this one. Get the input for every value, loan amount, credit history, and then we come to this Python file, come to this API. Here, what we said, the API should get the prediction model and then use this prediction model to predict the data. So what we have to do here is to load the pickle file, right? So just load pickle load. It's just the one we have written in a Jupyter file, but here we used this one. So here I can just use the code we had in Jupyter file. Let's save this to the decision model. Okay. Next, instead of using this index, we need to define another API. This API use the prediction model. Okay. So we reuse this code, but now instead of going to the root, the index, we have another API, prediction. And this prediction, the method is to get the input, okay? So here, and then a post back to the index. So the method should be a post. Okay. And again, we define this API. So what it does is, the first thing it does is to read the input from the index file. Okay. Having said that, we didn't create the input. So in this index file, we need to create a form, and so the users can put the variables here. I'll just copy this part. Okay, I don't have time to go over that. In this form, it gives the input, and then if you submit, click the button submit, it will return it to the URL. Which URL? Predict is the new address we are writing for, right? Here, see, if we go back to the API, the Python file, what we are writing is this is the address that ini.com root, just when you come into this website, and this is ini.com prediction / prediction. So this is the URL we are writing for. And so after the user submit the variables here, it activates this website, this web address predict. And what does this predict do? Okay, be consistent. Okay, what does this predict do is to read the features. Okay, the features are equal to maybe they are all int. Okay, I can see features and read the features from the form. So here, this method read in all the values from the form. Okay. And next, we can give the feature to the prediction model. Right? So there's an extra step. We need to transform these features to a NumPy array. NumPy array features. Okay, so we created this array, and then now we give this array to what? Give this array to the prediction model. Huh? So like what we did, decision model, and use this to predict. How we for this prediction model, and we give it the values we read in array. And then it should return the result 0 or 1. And we save it as in a variable result. Okay. Looks good so far. And the last step we have to do is to return this result to the index file. Right? Return this way. So I have to do is to return. Again, we have to use this render template to read the HTML file. So here I need to present this result, and we have to use another text, for example, Here I say result is, and then use this as a variable x. I just say x, okay. So this x should be fetched from the API from here. So x equals result. Okay, I guess that's all we need. Good. So we have how many variables we have here? We need to create the same amount of variables. How many variables we have? Let's see. 1, 2, 3, 4, 5, 6, 8, 9, 10. Okay. So instead of 3, we will have to define more variables here. Define more inputs so they can import all these 9, right? 9 variables. Was this 9? Was it 9? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. No. 1, 2, 3, 5, 6, 7, 8, 9, 10 features actually. So we needed to get 10 inputs. Use 10 inputs here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And these could be other names. It could be the names. I guess I can just use this. Dependence. Right. Okay. Let's come back, refresh this website. prediction method. Okay. Model 3 Pico. I believe we did copy it. It is here. It is here. Model 3 Pico. Do we see anything wrong here? It tells us no such file or direct Model 3 Pico. It is, and we did import this.
You try to get to the template, try to get to the page of the
With the import
that shows up the form.
here.
Yeah.
Now this,
Or did you already load that?
I should load it in the API. This Pico file. So looks correct. Pico.load. RB. And this is the exact same spelling. Okay. I'll just delete this folder and reload it again.
Is your,
Mm.
in the file structure, is your model supposed to be in model 3 also?
In the file structure, what?
Yeah, well, the one above that model 3 folder just says model dot above the system tree folder.
What did you say?
The file right above that, the system tree folder, it says model dot pickle.
Model.pickle?
Yeah.
Oh,
I didn't have to
This, yeah, this could be a convention. You have to name it model. Let's try this again first, and if not, let's try to change it to model. Okay, it works now. So it just needed to be refreshed. It looks. Prediction. Yes, I did mean predict. Okay, so this is not consistent with the name we used here. That's why. Okay, here it goes. It works fine. Although you need to be prettified a little bit. Let's try this. Gender, just income. I didn't change these. Okay. Yeah, I believe this last one. This one is the credit history. I put 0 again. Doesn't matter. Okay, then did return 0 as we did with in a Jupyter file. So looks good. And in your project, after you finish the step, yeah, just use the HTML, CSS to make it a little bit prettier. Okay, in your project. So these are the basic steps for building an API. So next question I have is, see, when we build the model, sometimes we have to transform the features. In k-means, in k-nearest neighbors, we have to normalize the data, right? So what if we use the normalized data? See, when you use the for the prediction model, it gets the numbers from 0 to 1. It was normalized, right? But when the user import the data, it will still be height is maybe height is 200 centimeter, or weight is 60. So when the user imports that, the prediction model in Pickle, it only saved it only used the data from 0 to 1. And now you have input the data from to 100 and 200. What you have to do is to transform the inputs into normalize the data, right? So the first thing I think of is to do it manually, like to calculate the mean and the max value for each feature, and then use that to normalize the data, the input data manually. And actually, you can also save this scalar. Save this scalar to Pickle file, and in the API you're building, you load this scalar again, and use this scalar to fit the data. Okay, fit the input data. So that's a simpler way than what I think of to manually get the mean and max for each feature, and then to get the input value and to minus minimum value, and then divide by max to minus mean. So this is much easier. You can use this way to normalize the input. And the second question, sometimes we use the dummy variables, and in the dummy variable, one feature like a rating, it's changed to 3 or 4 or 5 dummy variable, rating 1, rating 2, rating 3, right? However, when you build the client portal, you just ask him to rate from 0 to 5. What we can do is that. So you have to, in the Pickle model, the model is saved the Pickle. It used the 4 features, rating 1, rating 2, rating 3 for different rating values. So, and the input you get is just a 1 rating value from 0 to 4. What you have to do is to change this input into dummy variables. For example, here, feature 1, normal feature. Feature 2 is a categorical rating feature from 0 to 4. Okay, and you read in each feature. Here we read in the input from the index file from the client portal. Right? And now the features, it has many variables. Feature 1 is a normal variable, and feature 2 was a dummy variable, was transformed to dummy variable. What we can do is to transform this into dummy variable here also in the API. If the feature 2 is 1, okay, I create another feature, another variable, feature 2 underscore 1 equals 1. And if the feature 2 equals 2, okay, I create a second feature, feature 2 underscore 2 equals 1. Or if the feature 2 rating, if the rating is 3, okay, feature 2 underscore 3 equals 1. You have to have the same number of dummy variable as the prediction model. Okay, if the prediction model has 5 variables, you have to create 5 variables here, and then you can put back into the NumPy array. So instead of this number of feature you have, now you have feature 1, feature 2 underscore 1, feature 2 underscore 2, underscore 2, 3, maybe 4, and then the other normal variable, feature 3, feature 4. Okay? You have to take the extra step to transform those into dummy variables. Okay, that's what I think of when the input and the prediction model is inconsistent. So what other steps? I don't think of any other steps that we transformed the features variables, right? Do you think of any?
Transform like in function.
Yeah, like you change the value for the in the prediction model. Over sampling those don't change the values. As we did. I think that's only 2 steps in feature engineering. You change the feature value. One is normalization, or standardization. The second is you change the dummy variable. So if your prediction model has those 2 steps, you have to take the extra steps. Use it. Yeah, so all these other duplicates, these we do not change the variable. Normalization, balancing, you just add the cases, so it doesn't change split. Yeah, these all don't change the features. So only these 2 steps, you may have changed the input, and you have to make the inputs and the variable in the prediction model consistent. Okay. And if you had any errors, any bugs when you are deploying your project, you can just email me. Okay. Any question about today's lesson? Okay. Okay, I think that concludes our semester. I really thank you all for your hard work. I enjoyed it very much. I hope you too feel the same way. And in the week of November 28th, I'd like to set up individual meetings with you all for the project 3, okay?